Assalamu alaikum. I am Sumbul Zehra, lecturer in physics at Sir SyedGovernment Girls College. With the support and guidance of our very honorable Principal Professor Khalida Parveen and for my B.CS students, today I am continuing my lecture series which is on the topic of Maxwell equations. Now, today we will study what are Maxwell equations. In electricity and magnetism, we have studied so many phenomena right from electrostatics up to electromagnetic induction in which EMF is generated. So there are so many phenomena, so many relations, so many equations are there, and this study was done maximum by Maxwell. Maxwell selected 4 particular relations, worked on them, and he declared that these are the 4 equations on which the complete electromagnetism can be explained. So, complete magnetism is based on 4 fundamental relations known as Maxwell's equations. It is not that Maxwell discovered that, they were discovered by Gauss, Faradays and Amperes, but Maxwell worked on them and explained that these are the 4 equations on which complete electromagnetism is based and can be explained. So we'll study those 4 equations, and these 4 equations are famously known as Maxwell equations. So the first Maxwell equation is Gauss theorem in electricity, which is close integral E dot ds equals to q upon epsilon naught. This is the fundamental relation which says wherever there is charge q, there will be an electric field, and wherever there is electric field, it cannot exist without charge. So wherever there is electric field, here I need not to ask is there any charge, because electric field cannot exist without charge. It cannot be created without charge. There has to be a charge. Similarly, if there is a charge, we cannot ask, is it creating an electric field? No, we don't need to ask it, because any charge will always create an electric field. And the relationship between the two, how much electric field is created if we cover a charge around it with a surface area, then electric field multiplied by surface area, that gives us the quantity of charge. More is the charge, more is the electric field. Increasing the surface area, then intensity will decrease. All this we have studied in Gauss theorem of electricity. Now, second we have Gauss theorem of magnetism, which is close integral B dot ds equals to 0. How it is so important? It says that the magnetic field is always a closed line, or the magnetic lines are closed field lines. We have seen that there are no starting point, no termination point for the magnetic field, and ending at the same point, so complete circle it describes. In contrast to electric field, it starts from positive charge and terminates at negative charge wherever there are positive and negative charges. It also states that our earlier thinking that there is a north pole and there is a south pole. It is not correct. There is no north pole, no south pole. There is nothing, no entity, north pole or south pole. It is only one same source which is observed from both the sides. From one side it appears to be north pole, and here it appears to be south pole from other side. All these things come in second equation. Now, third equation is Faraday's law of electromagnetic induction. We have studied E equals to minus d phi b upon dt, means rate of change of magnetic flux is equal to EMF induced. Now, if we expand it a little, EMF is equal to voltage, which is equal to integral E dot dr equals to d by dt, and flux is equal to B dot A. I draw your concentration on E and other is dB by dt. Others in equation are constant. We have seen that wherever there is a change in magnetic field, we always get an electric field. If magnetic field changes, it creates electric field. So this is the description of Faraday's law of electromagnetic induction, that if magnetic field changes, it creates electric field. Now, fourth equation is Amperes law, and it is corrected by Maxwell, which is integral B dot dl equals to mu naught into IC plus ID, where IC is the conductor current and ID is the displacement current. Now, if we extend it, integral B dot dl equals to mu naught IC plus mu naught ID, and ID is equals to epsilon naught d phi E upon dt, which we will study in our next lecture, what is displacement current. So, अभी आप इसको छोड़ दीजिए. This again we can write integral B dot dl equals to mu naught IC plus mu naught epsilon naught d phi is equal to E dot A upon dt. Now, in this equation, we have observed one very important thing. IC is a conductor current, which is known as conduction current at a space where an electric field is changing, and that mathematical expression is dE by dt, change in electric field. What does it creates? It creates a magnetic field. Change in electric field creates magnetic field. This is an important conclusion of Amperes' Maxwell law, that changing electric field creates magnetic field, which is opposite of Faraday's law, in which we have studied that change in magnetic field creates electric field. So, these are the four Maxwell equations. I will repeat it once again. An electric field is created by electric charge. They cannot exist without each other. In magnetic field is a closed-in field always. There is nothing as North Pole or South Pole separately. Third equation is changing magnetic field creates electric field, and fourth is changing electric field creates magnetic field. So these are the four general effects of the Maxwell law, which we have to remember for our understanding. So Maxwell did many calculations in electromagnetic field, and he is supposed to be the masters of all. He is the one who proves that light is electromagnetic wave because of its velocity. He found the velocity of electromagnetic wave to be 3 into 10 to the power 8 meters per second. He is the one who said that electric field of electromagnetic waves are transverse wave. Otherwise, we used to think that they are longitudinal. So many credits goes to Maxwell. We have studied four equations which are popularly known as Maxwell equations. So on the basis of that, we studied nature of electromagnetic waves. Right. So that's all for today. Thank you so much.